Good morning, students. Today we will start with another topic, that is potential energy. Now take a rubber band, hold it at one end and pull from the other. Release the band at one of its ends. What happens? The moment you release the band, what will happen? The band will tend to regain its original length or original position. Means the band has acquired energy in its stretched position. So this is due to the potential energy. Let us understand by another example. When a child lifts a football from the ground and places it on the top of a table, some work is done on the ball. Now, if this football falls down from the top of the table and hits another football lying on the ground, which is stationary, okay, or at rest, then the football lying on the ground is displaced from its position. This simple activity shows that a falling football has the potential to do work. So anything capable of doing work possesses energy. Therefore, a football placed on the table also possesses energy. This energy of the football lying on the top of the table is known as potential energy. Now the question arises, from where this potential energy came in the football lying on the top of the table? In fact, the work done by the child to raise it to the top of table from the ground is stored as energy. This stored energy is known as potential energy. So what is potential energy? The potential energy is the energy possessed by an object by virtue of its position or shape. For example, let us understand by another example. Water stored in a dam has potential energy due to its position. Then take a toy car, wind it using its key. You all have seen a toy car using its key. You just wind it using its key. Place the car on the ground. Will happen? The car will start moving. Now, from where did it get the energy? It got its potential energy due to its shape. So, what happened? While you were winding the key of a toy car, the energy was transferred to the spring inside and stored as potential energy. Similarly, a stretched or compressed spring has potential energy due to its shape. A stretched bow and arrow has potential energy due to its shape. Okay, and the potential energy stored in the bow due to the change of shape is thus used in the form of kinetic energy in throwing of the arrow. Now, potential energy of an object at a height. An object increases its energy when raised through a height. This is because work is done on it against gravity while it is being raised. The energy present in such an object is known as gravitational potential energy. So there are two types of potential energy, gravitational potential energy and elastic potential energy. The potential energy due to its shape is known as elastic potential energy, and potential energy due to its height or position is known as gravitational potential energy. So in this class we will be learning only about gravitational potential energy. So whenever we will be talking about potential energy, we will be talking about gravitational potential energy, whether it is mentioned or not. Okay, now let us derive an expression for the gravitational potential energy of an object at a height. Okay, so consider an object of mass m. This is an object of mass m which is raised to a height h, okay, against gravity. So earlier the body was in the ground at rest position, then it was taken to a certain height, it was raised to a certain height h, and it was kept it at this position. So the minimum force required to lift the object from the ground will be equal to the weight of the object. Now, what is weight? That is equal to m into g. And what is the distance traveled by the object? That is h. So S is equal to h. Now we know that work done is equal to F into S. So what is F? F is the weight of object, that is m into g. And what is S? S is h. So W is equal to mgh. Now this work done against force of gravity is equal to the potential energy or gravitational potential energy. So potential energy, the expression for potential energy is mgh. So children, there are few points which you have to take into consideration while understanding about potential energy. That potential energy is stored in the body or an object. Potential energy of a body lying on the surface of the earth is taken as zero. Why? Because h is zero. So it is also, when it is lying on the surface of the earth, it is taken as zero. Okay. Potential energy of the body increases as the height of the body from the surface of the earth increases. As the height increases, potential energy also increases. Potential energy of the body decreases as it falls towards the surface of the earth. So as the height goes on decreasing, the potential energy also goes on decreasing, because we know that potential energy is equal to mgh. Then gravitational potential energy of a body or potential energy of a body depends upon the difference in height of the initial and final positions of the body, and does not depend upon the path followed by the body in going from initial and final position. So let us understand this point. Now let us understand this part. Suppose that we have a ball, okay? Initially it is at ground at position A, and it was raised to a height B, okay? And here height is h. So suppose there are two ways of taking the ball from A to B. So this is path 1. This is the first way. In this case, what will happen? Simple. What will be the potential energy? That will be equal to mgh, because the weight of the object is mg and height to which it is raised is h. So mgh. Now let us take another uh, way of taking the path from A to B. Suppose that initially the ball is at A. Okay. Now from here I have taken this ball to A1. This is another position, and its height I have taken as h1. From here I have just shifted it at the same or at the same height to A2. And then again I have taken it to B. Okay, this is second way, means I have taken the second path. There are two paths I have taken, and this is the height is h2. Total height from the ground is h. Now I'm just trying to explain that potential energy does not depend upon the path it is followed, but it only depends on the height of the initial and final positions, difference in height of the initial and final positions. So if in the first part, though the height is the same, so the potential energy is mgh, it is just, we are just taking straight to A, from A to B. Now from in the second case, what we are doing, for taking the ball from A to B, I'm taking this path, okay, but the height remains the same. Now what happens when the ball is raised from position A1, okay, to A2? When it is taken from A to A1, what is the height it is taking? It is mg. It will be, what will be the potential energy over here? It will be mgh1. Okay. Now from A1 to A2, no work will be done against gravity, because force of gravity acts perpendicular to the displacement of the ball. Thus, potential energy of the ball at position A1 and A2 is same. Hence, there is no change in gravitational potential or energy of the ball in going from A1 to A2. Now, when the ball is raised from A2 to B, okay, means if the ball is raised through height h2, then the gravitational potential energy of the ball at point B, okay, at this point, at point B will be, this is at A1, at B it will be, from A2 to B it will be mgh2, isn't it? Now, what is the total gravitational potential energy of the ball at position B? The total total gravitational potential energy will be equal to mgh1 plus mgh2, or mg h1 plus h2. Now, what is this h1 plus h2? This h1 plus h2 is the total height h. So, in place of writing h1 plus h2, we will write down mgh. Okay, since h1 plus h2 equals to h. So, what do we conclude? That gravitational potential energy of a body depends upon the difference in height of the initial and final position of the body, and does not depend upon the path followed by the body in going from initial to final position. So whatever path you follow, the potential energy does not depend upon the path. Now let us do 1-2 numericals based on potential energy. Calculate the energy possessed by a stone of mass 10 gram kept at a height of 5 meter. Take G as 9.8 meter per second square. Now M is 10 gram, so we will first convert it into kg. So 10 by 1000 kg, that 1000 into kg is equal to 1 by 100 kg. H is 5 meter, G is 9.8 meter per second square. So potential energy is mgh, that is 1 by 100 into 9.8 into 5, that is 0.49 joule. Next question. A bag of wheat weighs 50 kg. Calculate the height to which it should be raised so that its potential energy is 5000 joule. Take G as 10 meter per second square. Now M is 50 kg, potential energy is 5000 joule, G is 10 meter per second square. We have to find out H. So we know that PE is equal to mgh. Just put the values. 5000 equals to 50 into 10 into H. So H is equal to 5000 by 500, that is 10 meter. So children, for today this much only. Thank you.